For most angles, the values of their trigonometric functions are going to be irrational numbers, like e or pi. Now, there are a few, however, where we can determine their exact values. Now, I'm going to be honest with you about these numbers. They aren't very useful in practical situations. It's unlikely that a practical situation will come up with one of these very specific values. However, they are useful as teaching tools, and we're going to use them throughout the rest of the class to illustrate practically every concept we're going to be discussing. So first, take a look at this triangle, Geometries classic 45, 45, 90 triangle. Now, it's an isosceles triangle, so we know that the lengths of the legs are all the same. And for convenience, let's make both of them equal to 1. All right, now this makes the hypotenuse equal to the square root of 2. You can calculate that using the Pythagorean theorem, or you could just remember the ratio from your high school geometry class. Now, with these values, we can calculate the 3 trig function values using their definitions. The sine is the opposite over the hypotenuse, which is 1 divided by the square root of 2. The cosine is also 1 over the square root of 2. And the tangent is 1 over 1, which is just 1. Now, these are almost the values, but we still need to get the square roots out of the denominator. That is, we need to rationalize them. So multiplying the numerator and denominator by the square root of 2 over 2 gives us the square root of 2 over 2. And we're going to get the same value if we do this same process. We're going to get the same result down here for the cosine. All right, so we can do a similar set of calculations with Geometries 30, 60, 90 triangle. And in this case, the side opposite the 30-degree angle is going to be 1. The side opposite the 60-degree angle will be the square root of 3. And the hypotenuse will be 2. All right, now using these values, let's see, the sine of 30 degrees, that's opposite over hypotenuse. That's going to be 1/2. The cosine of 30 degrees, that's adjacent over hypotenuse. That's going to be the square root of 3 over 2. And the tangent is opposite over adjacent. That's 1 divided by the square root of 3. And again, I'm going to rationalize this. I'll multiply the top and bottom by the square root of 3. And this is the square root of 3 over 9, which is the square root of 3 over 3. Okay, now just for practice, try walking through the same reasoning and see if you can get the 3 values for a 60-degree angle. All right, we're using the same definitions, but from the opposite perspective, right? With the other angle, the sine of 60 degrees is the 60-degree angle's opposite side. That's the square root of 3. So this is the square root of 3 over 2. The cosine of 60, the 60-degree angle's adjacent side is 1. So this is 1/2. And the tangent is opposite over adjacent. That's the square root of 3 over 1, which is just the square root of 3. Okay, now you need to have these values at your fingertips, since we're going to be using them repeatedly throughout the rest of the class. One way to do that is to make a quick table like this one and have it in front of you while you're studying. Over time, with lots of use, the values are going to become increasingly natural to you, and you're going to become less dependent on actually having that table right there. Now notice the way I've done this, right? All of the examples I've been doing so far, whenever I talked about angles or the measure of an angle, I did everything in degrees, because degrees we're all used to from all the way back to grade school even. So it comes very naturally to us. And when you're trying to learn something new, I kind of wanted to minimize the distraction. So I went with a measure that you were most comfortable with. However, you do need to get used to thinking in terms of radians as well as degrees, which is why when I laid out the table here, right, I put the angles on here in both measurements. And you can confirm I got them right? You remember our trick for converting radians to degrees? Just replace the pi with 180, right? 180 divided by 6 is 30. 180 divided by 4 is 45. I should put the degrees in here, right? And 180 divided by 3 is 60. Okay, so at the beginning of class, at the beginning of this series, I said that the triangle method is a good place to start, but it has some limitations. The biggest one is that it only works for angles that you can find in a triangle, in a right triangle. That is, ones that are between 0 and 90 degrees. Well, real-world situations, for example, a spinning machine part, aren't going to be limited to that range. So in the next lecture, we're going to develop a more general definition that we can use to find the trigonometric values of any angle.